All right, in 1.6 video 2, we're going to tackle this story problem. It says you plant a small tree in your front yard and feed it and water it regularly. 1 month after you planted the tree, it's 6 feet tall. 5 months after you planted the tree, it's 14 feet tall. Okay, you plant a small tree in your front yard, feed it and water it regularly. 1 month after you planted the tree, it's 6 feet tall. 5 months after you planted the tree, it's 14 feet tall. The first question I'm asking you for this, oops, not that, is write the independent and dependent variables for this situation. All right, well, let's think about it. A tree over time is growing. Well, I always think time is on that x-axis. It happens no matter what. It's independent. So then I think the height of the tree depends on the time it's been in your yard. So I definitely think the independent variable is time, and the dependent variable is the height of the tree. All right, seems pretty logical to me. So then the domain and the range, well, we write that, remember the D stands for domain, R stands for range. Well, time, it would make sense for this to be in quadrant 1. The time would be greater than or equal to 0, where 0 is the moment I plant the tree, and it would go from there. I'd maybe like do time in months. You could in days, I suppose. That's up to you. And then it talks about the height of the tree being 6 and 14 feet tall. Well, 6 is pretty close to 0, so I think I'm going to just say my range is greater than or equal to 0. You can't have a negative height of a tree. If you wanted to get picky and have the range be more like y is greater than or equal to 5, you can, but you don't have to be that picky when the numbers are so low. All right, next it says, write a linear equation that describes the situation and explain your assumptions. Well, let's think about this. What does it tell me? 1 month after you planted it, it's 6 feet tall. So I think I've got an ordered pair if I'm dealing with time and height. So remember, time is the x value, the independent. Height is the y value, the dependent. So I've got 1 month, 6 feet, and then I've got a 5 months, 14 feet. To get in a linear equation, I need the slope and the y-intercept. Well, slope, here's a blast from Algebra 1 past, is you do the change in your y values over the change in the x. So let's go ahead, our y values are 14 and 6, so 14 minus 6, and then the x values are 5 and 1, 5 minus 1, so 14 minus 6 is 8, 5 minus 1 is 4. It looks like I have a slope of 2. So that's getting me my linear equation, y equals 2x, but now I need that y-intercept. I need to know what's the height when I'm at 0. Well, if my slope is 2, looks like if at 1 month it's at 6, 0 months it's going to be at 4 because I would add 2 each time. So I'm going to do a y equals 2x plus 4. The textbook would call it y equals 4 plus 2x. If it asked for an explicit formula, it'd be u sub n equals 4 plus 2n, but it didn't ask for that. It just asked for a linear equation, so I'm going to stick with this one right here. The assumption I'm going to make right now is that it grows at a constant rate, that we have an arithmetic growth here, which I don't think is really true for trees, especially in Minnesota with the weather changing. Trees have a growth season and a dormant season, so parts of the time of the year they're growing, other times of the year they're not. So the assumption I'm making is it grows at a constant rate, which I don't think is quite true. And then another, kind of to expand on that, does a linear representation make total sense for this situation in real life? I'd say no, because of what we just talked about, and also no, because a tree will eventually stop growing. Based on what kind of tree it is, they get it to be a certain height. Some trees get super tall, some trees don't, and they kind of just level out. So I think realistically, trees' growth would be more geometric where it would level out, but we just don't have enough information, so we're sticking with linear here. All right, that's it.